Good morning, students. My name is CH.S.V.PRASAD and I am working as Senior Lecturer in Electrical Department, Government Polytechnic, Yadgirgutta. As we are continuing the chapter 4, that is the characteristics of three-phase induction motor. Today we will cover. In the last class, we derived the power equation, torque equations, and the relation between torque and the powers, the construction, working principle. So all these things we have covered in the last class. Today, we will go through the conduct of no load test and blocked rotor test on induction motor and to draw the performance curve of induction motor and draw the circle diagram from this no load test and blocked rotor test. Next, can be able to draw performance curves of induction motor. So these things today we will cover. Testing of induction motor. There are two types of test. Why we conduct the test? To know the performance of induction motor, we are conducting the test. So that is no load test. Next one is blocked rotor test. And next one is stator resistance test. So these three tests we will conduct to know the performance of the induction motor. So if you consider no load test of a induction motor, the name only it says we are not applying any load on the induction motor. From no load test, we can find out no load losses and no load power factor and no load resistance or not and no load reactance x naught. So this test is same as the no load test as on transformer. So the same thing, we are not applying any load on the induction motor. So this condition is called no load test. So in this case, what we can calculate? We can calculate no load losses, no load power factor, no load resistance or not, and no load reactance x naught. So from this no load test or from this no load, what are the no load losses? That is core losses and small amount of copper loss in the stator. So as there is no load means there is no load and there is no output. So then what happened? Then automatically the core losses and small amount of copper losses it will gives. So next what he gives, it gives rotor copper losses which is negligible. So core losses and small amount of copper losses in stator. The rotor also has the losses. It is negligible due to low rotor current at no load and friction and windage losses. So no load losses contains these things. It contains core losses and a small amount of copper losses in the stator, rotor losses and friction and windage losses. So next one is no load test. The circuit for no load test is this one. So that means supply is given to the stator. So when we give in the supply to the stator, we have to apply a voltmeter, ammeter, and two wattmeters. They are connected like this W1, W2. So this is the connection diagram for a no load test. So when we are applying the no load test, so why is the test conducted? To know the performance of the induction motor, such as losses and efficiency. So in a no load, when the motor is running on no load, it develops only a small fraction of full load torque in order to overcome friction, windage, and iron losses, in addition to the small amount of copper loss in the stator winding. So the speed of the motor is very much nearer to synchronous speed. Since motor is on no load, so the slip at no load is very small, and therefore the load resistance is RL into 1 minus S by S. So the no load input gives friction and windage losses, core losses of the stator, and copper losses of the stator. So this is the circuit diagram where we apply the give the supply to the stator through two wattmeters W1 and W2. So total power is equal W1 plus W2 through ammeter and voltmeter. So this is the equivalent circuit what we can draw from no load. So V1 is the supply voltage, I0 is the no load current, and IW is the working component, and I mu is the magnetizing component, R0 is the resistance, and X0 is the no load reactance. So this is the equivalent circuit of a no load test of a induction motor. So see here how the stator is rotating. Rotor, this is the rotor, this is the stator. Outer frame is stator, and inside that one the rotor is rotating. And this is the equivalent circuit. This is the CH.S.V.PRASAD supply, voltmeter, ammeter, and two wattmeters. That is W1 plus W2. Okay. So how to perform the no load test? When a three-phase supply is given to the stator winding and rotor rotates freely without mechanical load on its shaft, the power input the power input, no load power input, that is W naught, to the motor is measured by two wattmeters, that is W1 and W2. So power input is equal to W1 plus W2. The no load input power W naught is equal to the mechanical losses and core losses of the motor. So the no load power supplies mechanical losses as well as core losses. To more accurate, the stator copper losses is neglected. So why it is neglected copper losses? The stator current is the no load current is very small. So the square of the current, that is I square R, again it is very less. So that stator copper losses are neglected. So let power input is W naught. V is one is the applied voltage and I naught is the no load current, and so no load power factor cos phi is equal to W naught by V1 into I naught. So when we give the supply to the motor at no load, we take the readings of W naught, that is W1 plus W2. Voltmeter gives the V1 reading and ammeter gives I naught reading. So cos phi naught is equal to W naught by V1 and I naught. So W naught is equal to V1 I naught cos phi naught. So R naught is equal to V1 by IW, that is equal to V1 by I naught cos phi naught. Similarly, X naught is equal to V1 by I mu, that is equal to V1 by I naught sin phi naught. Hence, IW is equal to working component of no load current I naught and I mu is equal to magnetizing component of no load current I naught. Note down these values. These are important when we are doing problem on no load test as well as circuit diagram. For drawing the circuit diagram, it is required. Note down this. I naught. How you can get IW, I mu, R naught, X naught from this ammeter, voltmeter, and wattmeter reading. So note down this I mu, IW, R naught, X naught. R naught, X naught, IW, I mu are useful to draw the equivalent circuit of induction motor under no load, which is equivalent to transformer on no load. So no load procedure, test procedure. No load losses for different voltages can be plotted as shown in the figure. These curves are obtained from the data of no load. So this is the power input. So input power, input current, and this is the input voltage. So next one is blocked rotor test. So, so this is the curves of no load test. From this no load test, so where it shows the characteristics. If the number of readings of W naught at a different state or applied voltage are taken, we can plot the curves as shown in figure. So, so from this we can calculate R naught, X naught, IW, I mu cos pi naught. So next one is blocked rotor test of a induction motor. So it is also known as locked rotor test or blocked rotor test or short circuit test, and it is equivalent to the short circuit of the transformer. So the name only says blocked rotor test. How you can do the, it is equivalent to short circuit test of a transformer. So how it is equivalent to short circuit of transformer? By making the blocked rotor test. How you will do this test? We will block the rotor so that the rotor is not possible to rotate in any direction. The rotor is blocked. This blocked rotor test is also known as short circuit test. This is similar to short circuit test on a transformer. So this test is used to find out total resistance of the motor, total leakage reactance of the motor, and that is referred to stator. And next, power factor on short circuit. So these are used. Locked rotor test is used. It is also known as short circuit test. It is used to find out total resistance of the motor, that is R01, and total leakage reactance X01 referred to stator, and power factor on short circuit. So in this case, first we will block the rotor so that it's not possible to rotate, and we will apply the rated current and take the readings of ammeter, voltmeter, and wattmeter. Here you can see this rotor is blocked with the rotor S1, S2 springs and the belt. By using belt, the rotor is blocked. The rotor is not going to rotate. And we apply the rated current and take the readings of ammeter, voltmeter, and wattmeters. So W1 plus W2, that gives the input power at under short circuit condition. The rotor is locked by means of a brake. Therefore, it is called blocked rotor test. The rotor winding are short circuited at slip rings. Slip rings. If it is wound rotor type. If it is wound rotor type. So next we apply a reduced voltage to the stator terminals, that is up to 10 to 20% of the voltage only. So for this voltage only, it will flows full load current in the stator. That by seeing the ammeter reading. The ammeter shows full load current at a 20 to 10 to 20% of the normal voltage only. When the rotor is blocked, slip is equal to 1. This means under case of a blocked rotor test, the slip is equal to 1. Why the slip? What is S? Slip is equal to Ns minus Nr by Ns, where Nr is equal to 0. So that is Ns by Ns. So that is equal to 1. So the equivalent circuit of a motor is exactly like a transformer short circuited secondary. So if you draw the equivalent circuit, it will be like this, where VSC short circuit voltage and ISC short circuit current. So VSC and ISC are per phase values of applied voltage and current. WSC is the total power input. WSC, that is called root 3 VSC ISC cos phi SC. So therefore cos phi SC is equal to WSC by root 3 VSC into ISC. So this is the short circuit blocked rotor test, or it is also called short circuit test, and it is equivalent to the short circuit test of a transformer. So the total resistance R naught 1 is equal to Z naught 1 into cos pi s. So that is equal to VSC by ISC. That is voltage by current, which gives the resistance, that is impedance into cos pi, which is equal to R1 plus R2 dash. That means R1 is the primary resistance and R2 is the dash is the secondary resistance referred to primary. That means the secondary resistance is transferred to the primary side. So the total reactance referred to the stator x naught 1 is equal to z naught 1 into sin pi. So that is VSC by ISC. So that is x1 plus x2 dash, where x1 is the primary reactance and x2 dash is the secondary reactance referred to primary. That means we have to convert the secondary resistance towards the primary side, that is x1 plus x2 dash. From this test, we can plot a waveform between input voltage and current. This is like this is the input voltage, this is the input current and input power. Input current is a straight line that passes from the origin, and this is the power equation as given in a dotted. It is also going from origin. So note down this blocked rotor test. So from the blocked rotor test, we can calculate R naught 1 and X naught 1, where R naught 1 is the total resistance referred to primary and X naught 1 is equal to total reactance referred to primary. So that is R1 plus R2 dash. R2 dash is the secondary resistance refer to primary. So similarly, x naught 1 is equal to x1 plus x2 dash. X2 dash is the secondary reactance referred to primary. So that is V by I cos phi, that is equal to V by I sin pi. So this is the graph. So to calculate the stator resistance, it is necessary to determine the value of R2 dash to find out the shape of the speed torque curve. Slip for float condition, or for this purpose, the stator resistance R1 can be measured by passing DC current through stator winding. So this is used to find out the stator resistance. The ratio of DC voltage across the phase to the DC current that gives the R1 value. R1 is equal to DC voltage by DC current. So therefore, rotor resistance as referred to stator, that is R2 dash is equal to R01 minus R1. So there is no easiest method to separate the two reactants X1 and X2. So in most motors, X1 and X2 dash are assumed as equal values. So after getting these no load test, after doing this no load test, block rotor test, and rotor resistance test, by using these test results, we can draw the circle diagram. So construction of circle diagram. So the aim of this method to draw a circuit diagram is to plot the locus of the current drawn by an induction motor. It is referred to as a circle diagram. So to construct a circle diagram, we require the data from no load test and block rotor test. By using these two tests, we can draw the circle diagram on the graph. So how we can draw? All quantities are to be considered for phase value. We have to convert that all values current to voltage and power, that all must be in per phase value. So from no load test, we can get I naught and phase angle pi naught. So we have to take these two from no load test, I naught and pi naught. Then from short circuit test, we have to take ISC, no load current, short circuit current, and VSC is the voltage, and PSC is the power factor obtained from the blocked rotor test. So ISC, VSC, and phase angle phi SC. Thus, this current must be converted corresponding to the rated voltage of the motor. So this I1, first you have to check ISC. So what is the short circuit current? Either it is equal to the rated current of the motor or not. If it is not, then convert that into rated voltage. So short circuit current for normal voltage, so that is ISN is equal to ISC into V1 by VSE. By knowing the above data, the circle diagram can be drawn. So what we required? We required no load current I naught, no load power factor pi naught. Next, short circuit current ISC and power factor pi SC. Then we have to calculate short circuit current under normal voltage, that is ISN is equal to ISC into V1 by VSC. So V1 is the rated voltage, VSC is the voltage which the short circuit is blocked rotor test is conducted, and ISC is the current at blocked rotor test, that is short circuit test. So this method aims at plotting the locus of input stator current I1 for different values of slip. The circuit diagram can be constructed from no load test and blocked rotor test. In addition to above two tests, it is necessary to make measurement of stator winding resistance by stator resistance test. In addition to the above test, it is necessary to make the R1 also we required. That is we got from stator resistance test. Step 1. How we can draw? So from no load test, three-phase induction motor, line voltage V1, total power input, no load current I naught, and power factor phi naught is determined. This is the step 1. So what we have to do? By selecting the Popper scale, so I naught can be drawn, that is OA, lags behind the supply voltage V1. So we have to take V1 on y-axis and I on x-axis by pi naught. With the applied voltage V1 as vertical reference axis as shown in the figure, this locates the no load current I naught opposition on diagram. So see here, first we have to draw OA. This is I naught which lags the V1 by pi naught. So vector for I naught can be vector of E can be lagging pi naught behind the supply voltage V1 as shown in figure as shown below. First we have to draw by taking graph sheets. Next step 2 is from blocked rotor test find the short circuit current at normal voltage, that is ISN, by converting the data from lower voltage to normal voltage level, that is ISN is equal to ISC into V by VSC. So cos pi SC is equal to WSC by root 3 VSC by ISC. So you can calculate pi SC also. So we have to draw ISN at an angle of pi SC. So first step is we have to draw I naught, that is OA, that is I naught and the angle of pi naught. Next, we have to draw blocked rotor current. So that is ISN is equal to ISC into V by VSC. So cos phi SC is equal to WSC by square root 3 into VSC into ISC. So ISN is equal to short circuit current corresponding to normal voltage. So now we have to draw a vector OB that is equal to ISN at an angle of phi SC. So this is OP, this is phi SC. We have to draw, and we have from A we have to draw a parallel line to the x-axis. So this is OA we already drawn. Now we drawn OB, and we have to extend the line. We have to draw a parallel line from point A that is parallel to x. So with the same current scale, the vector OB represents ISN at an angle of phi SE with vertical axis OV1 lags vector. Next, vector OB represents the corresponding rotor current as referred to stator. Step 3. Join the line A, B, which represents the output line of the motor. So we have to join these two, A and B. This is the output line. We drawn OA that is equal to I naught at an angle of pi naught, and OB that is ISN at an angle of pi SE, and join A, B, that is step 3. So next, step 4 is the points AB lies on the point, these 2 points A and B must be lie on the circle diagram. To determine the center of the required circle, the line AD is drawn, which is parallel to x-axis. Here, like this we will draw, that is parallel to x-axis. Next, step 5 is to draw a perpendicular bisector of the line. AB is drawn. It cuts the horizontal line AD at point C. The point C is the center of the circle. See here. So what we have to do, we have to bisect the line AB and extend it so that it cuts the point here AD here. Take C here. So take AC as radius and draw the semicircle, that is A B D. A B D. So next step is now C as center and CA as radius. Draw a semicircle A B D as shown below. See here. So what we have to do here, we have to bisect the line A, bisect the line AB and extend that line so that it cuts the AD line at point C. Now take C as center and AC as radius and draw a semicircle, that is ABD. ABD. So from B, draw a vertical line to the x-axis, which cuts the x-axis at G and AD at F. and BF. In problem, if you given rotor copper losses and stator copper loss are equal, then put the middle point. Here B is to A and F shows the copper losses of stator and rotor. The point E from B, E shows the rotor copper losses, E and F shows the stator copper losses, where AE shows the torque line and AB shows the output line. So draw OX and OY, next OA at an angle pi naught, next OB at an angle pi s, and join AB. Then bisect the line A, B and extend it so that it cuts the AD line at point C. Now take C as center and AC as radius. Draw a semicircle which passes through the point A, B, D. So this is the drawing of, and from after drawing that, draw a vertical line from B and A. So that cuts AD at F, x-axis at E. Again here from A to x-axis H, vertical line. So take the, if both B shows the division, this AF shows the copper losses of rotor and stator. If both are equal, take the midpoint. AG is the torque line and OAB is the AG is the torque line, AB is the output line. Now draw A to get the maximum output. You draw a parallel line to AG like this and get the point P. This is a perpendicular bisector for the circle. Join PQ. This will give the maximum torque. This will give the maximum torque. PQ is the maximum torque. Now to get the maximum output, draw a perpendicular bisector to the line AB. AB is the output line. For this perpendicular bisector is this one, which cuts that point U. From U, you draw a vertical line, which cuts the AB line at V. So UV is the maximum output. And next, you take the point for maximum input. W is the at the middle, and join from here. You draw a vertical line. WC is the maximum input. So this is the curve. Rotor copper losses, stator copper losses, torque line. A is the torque line, AB is the output line. The seventh step is draw a vertical line from the point B up to point G, and it meets the line AD at point F. So the BG represents total input on short circuit. Step 8. Divide BF into two ratios. So that is rotor copper losses and stator copper losses. The line BF divides that point E. So B by EF is equal to rotor copper losses by stator copper losses. The line AE represents torque line or rotor input line. So summary, if you see what we covered construction of circle diagram. Data must be available from the no load test, blocked rotor test. We can draw circle diagram by using these two tests. First, draw a vertical line represents the voltage vector, that is V1. Then select a suitable current scale. Next, draw OA lags V1 by an angle pi naught, that is no load current I naught. Next, draw a line OB lags V1 by an angle ISE, which is equal to short circuit current for normal voltage. The vector OB represents the rotor current R2 dash as referred to stator. Next, fifth point is join AB, which represents output line. Next, draw a perpendicular bisector to AB so that it cuts the AD line at point C, where C is the radius. Take AC as C as center, take AC as radius, C as center, AC as radius, and draw a semicircle A, B, D. Now draw a vertical line from point B so that it meets the line AD at point F. Now divide the BF ratio so that it represents copper losses and stator copper losses like this. Point B by EF is equal to rotor copper losses by stator copper loss. Join AE, which represents torque line. So in this today class, they will ask the questions like this. Explain briefly how we can draw circle diagram from no load test and locked test. Next, explain no load test of a three-phase induction motor with equivalent circuit. Next, explain blocked rotor test of three-phase induction motor with connection diagram. You study this one and practice the circle diagram. If you have any doubt, ask me in the next class. Okay. Thank you.